So today we're going to begin our new topic of probability. And to begin with, we're going to do a little revision of some basic probability skills and then look at some graphs of distributions. So we're going to be using the Walker book, and I'll be going through the first few sections of that book. So the first sections of this book gives you a few formulas you're going to need to know. The standard normal distribution, in other words, the z-score, z equals x minus mu over sigma, the standard deviation. We'll talk a lot more about that, so if you don't know what those symbols mean, don't worry about it yet. There's also a glossary and some words that you need to find the definition of, and as we go through, we'll define these words, and you might also put some examples of some of those there. So you don't need to go through all those definitions just yet, but as we go, we need to fill that out because those words are going to be very important to you. So we'll talk about first about the ranges of values that probability can take. Probability is simply the chance that something can happen. And it can range anywhere from 0, meaning an event is impossible, to 1, meaning a certain event. So all probability has to be between 0 and 1. So if you do any of these and you get a probability greater than 1 or less than 0, then you know you have a problem. Right down the middle, the probability of 0.5 is 50%, 50-50 chance. Okay? So, and it can be anywhere else along that scale. A couple of different ways of calculating probabilities. If you have equally likely outcomes, for example, every possible thing is equally likely to happen, the probability is simply the number of favorable outcomes over the total possible outcomes. And we'll do a lot of those. So you'll see the example, the probability of a 5 or a 6 on a standard die. There is 1 5, 1 6, so that's 2, 6 total numbers on the die, so 2 out of 6. One thing that you will often see is that probability will be, if it's a fraction, it will often be reduced or simplified. You'll see it written both ways. I prefer the simplified version, but there are often times when you would leave it not simplified so that you could then add it or work with it. So you can write it either way, but if it was me for the final answer, I would like the simplified version. Okay. Then there's long-run relative frequency for probability. It's the number of time an event occurs over the total number of trials. And you're going to see it's pretty much the same formula, how many times something happens over how many times you do it. And it's just dealing with events where you have lots of different trials of an event. Okay? So for example, Anna is late to school. The probability of that is the number of times she's been late to school over the total number of school days. So you see that just means stretched out over time, okay? Not just a single event like rolling a die, okay? I want to talk about the notation for a moment. Remember that if you're dealing with probability, you have the probability of some event equals. So this notation is really important, and many times students forget to use the proper notation when they're talking about probability. If you don't include the P and then the name of the event inside, and you can abbreviate with initials, but make sure that the event is clearly named, then your probability is not correct. Okay? So here, the probability that Anna is late to school equals. You have to include that information. All right? Now, some more probability terms that you've probably seen in the past, but we'll remind you of. Expected number of outcomes. This is often just called expected number. That's the probability of an event times the number of trials. So, for example, if Anna is late to school, if the probability of that is 0.04, and there are 50 days in the term, then the expected number, or how many times we expect Anna to be late, is that probability times 50 days, so 2. Okay? All right. One other thing about probabilities, when we're talking about combinations of probabilities, we have more than one probability happening at a time. The connecting operation will determine what, connecting word will determine what operation you use. Anytime you see the word and in probability, you're always talking about multiplication. Anytime you see the word or, you're always talking about addition, right? So if you flip a coin and toss a die, so that's those two probabilities multiplied together. If you toss a fair die once and you get the number of that probability of an even number or a 1, that's an or statement. So we ended up taking those two probabilities and adding them together. Okay, so again, brief review, but an important review of some topics dealing with probability. All right, now we're going to be dealing with lots of probability. The first assignment that you're going to have is working on this page where you're just going to answer some questions based on probabilities and to see if indeed this probability is possible. So indicate whether it's right or wrong and justify your decision. For example, Mike calculated the probability of winning his game was 1.05. That cannot be, because probability cannot be bigger than 1. So all of these are just going to give you, there's going to be some kind of little word play or some kind of words that tell you that it's not correct or it is correct. So you'll put a plus or minus, a check or a cross in the box, and then give me a reason why. Okay. Another skill that you're going to need to have, and that is critical for working with probability, is you need to be able to look at graphs of distributions and determine frequencies for them. So let's talk about what that means. Now, if you can count, you can do frequencies. So here we are. The graph below shows test scores for 50 students. So we know that it's a total, this graph shows a total of 50 total students. Okay? And the frequency just means how many times something happens, or how many people. Frequency is how many. So the frequency going up the side just tells you how many. So you'll see that's 1, 2, 3, 4, 5, 6, 7, 8. You're probably familiar with the fact that many times they won't give every line of a graph, but you can fill in the blanks based on what they're doing. Here across the bottom, again, they're counting in 2s, but you know that the line between 2 and 4 is a 3. Okay, so we're just going to look at how we can read one. Each one of these boxes represents a student at a particular test score. Okay, or how many students in that particular test score. So let's look at this graph. Okay, how many students earned 12 marks? Right? Well, your score is on the bottom, the horizontal axis. The frequency is the vertical axis. So 12 marks is here. So that's 1, 2, 3, 4, 5, 6 boxes. So that indicates that 6 students earned that particular mark. So when you have just one of them, it's simply a matter of counting them. Pay attention to your scale here, though. They could be counting in different scales. This could have been 20, 40, 60, 80. So make sure you watch, because your scale can be represented different values. Okay. So again, they just show you there, going up. So 6 students made 12 marks. Now, what is the probability that the student got fewer than 10 marks? Well, fewer than 10 means that the probability for a student getting fewer than 10 means less than 10. So probability of less than 10. So in that case, it cannot include the 10, but it includes everything lower than 10. So all we need to do is count all the boxes that are lower than 10. 1, 2, 3, 4, 5, 6. So the probability that it's less than 10 is 6, and again, out of the 50 students. So there's the completed probability. P standing for probability of, and we told exactly what it was, and then the number. Now notice I didn't reduce it. Sometimes you'll see in the back that they will reduce it, sometimes they don't. Your choice, but I really prefer the reduced one. But all right, now, so fewer than, more than. This one wants fewer than 10 or more than 16, right? So 6 students got fewer than 10, 5 students got more than 16, so that means 11 out of 50 students, or 22%. So this one is a compound probability that 10 is bigger than your x, okay? But your x is bigger than 16. All right, so the number that you're looking for is on either end of that. So you'll simply count those up. Again, we know that there are 1, 2, 3, 4, 5, 6 from that side, 7, 8, 9, 10, 11. So it's 11 out of the 50 students. And they simply change that into a decimal and then change that decimal into a percentage. You can write probabilities either as a fraction, a decimal, or a percent. And they're usually pretty specific about how they want you to write them. Okay? All right. Let's see. They're also going to ask you to be to describe the shapes of graphs and distributions. And so if we look at a few of the points about these graphs, the lowest and highest values indicates where the x-axis the distribution is located. Lowest value means, of course, the smallest one. Highest value, the highest one. The range is simply found by subtracting those two, and that indicates what's called the width of the distribution. How many numbers are between, how much area is between, how long the line would be. The modes, these indicate the highest point of the distribution. So if you see here, this point on the top of that triangle would be a mode. This number would be a mode. This one has 2 modes, so it's called bimodal. Okay. You also, we talk about the shapes. So this one, where you see this nice soft curve, is called the normal distribution. Clearly that one's triangular, rectangular. This one goes all over the place, so it's simply irregular. And this one has 2 high points, so it's called bimodal. Okay. Graphs are the distributions of data can also be determined by or described by their symmetry. Not all of them are symmetrical. The irregular one there was not symmetrical, but all of these in number 5 were symmetrical. So you may describe a graph as symmetrical, or you may describe it as asymmetrical. And usually when they're asymmetrical, they're called skewed in one direction or the other. Now it's important that you pay careful attention to which direction it's skewed. If you have the long, thin part, that tells you the directions it's skewed. Most students want to say it's skewed to the right because there's more data to the right, but it's really that longer, thinner line that drags the graph off in one direction or the other. So this is dragging this graph off to the right. This one's dragging it off to the left. Okay? So it's the small part that doesn't seem to fit with the rest. That's the part that's skewing the data in one direction or another. Right. Okay. So if we look in these, all the data are between 4 and 18. Right? So 18 minus 4 gives us a range of 14. The mode is 15, and that's simply because that's the one that occurs most frequently. So the highest point of your distribution is 15, right? Halfway between there. The shape is almost triangular, but it's a bit asymmetrical, and since there's a lot more data sliding off to the left, this one is determined to be asymmetrical and skewed to the left. If you call this triangular, you wouldn't be absolutely wrong, but you'd be best to say almost triangular. You're going to learn that in statistics, it's very rare that you can absolutely say anything. Okay, so they're just going to give you some distributions, some graphs of distributions, and you're going to answer questions of them and calculate simple probabilities for those. Okay, be careful here. It says Jack, Queen, or King. This is not the or that means to add. This just means you want one of those three things to happen. Okay, so Jack, Queen, or King. So you'll add up these three columns. Okay, all right. So there is some simple information, a little bit of revision about probabilities, a little bit of a revision on how to read a probability distribution or frequency distribution. And so now you should have some homework. You can do everything in the Walker book up to page, let me see where this is going. Fun for you, this is up to page 15. So the homework is everything up to page 15. All right. Thanks. Next time we meet, we will be using our calculator, so make sure you have your calculator handy, and because it's going to be used heavily for the next few sections. Bye.